Bismillahirrahmanirrahim. Least cost trees. How do we find the best distance, or the best route rather, from a source to a destination? This is a very important question that we face in networks. So in reality, we have a huge number of routers, right? There's a huge number of routers sitting there, and there is more than one way of reaching from a source to a destination, right? There's more than one way of going from the source to the destination. So we need to come up with a solution which will help us decide what is the best route from the source to the destination. There are different ways in which we can do this. We can calculate this based on the least number of hops, for example. So we could have 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7. Okay, so this route would be the minimum route in that sense, because you have 1, 2, 3, 4, 5, 6, 7. Okay, so any one of these routes would be the best route, you could say, if we are considering it from a point of view of hops, minimum hops. But it could be possible that among these two routes, they're both having 7 hops, right? But among these two routes, one of them could have less delay than the other one. So in this case, if our aim is that we are minimizing the delay, then we would choose this route. So this is how it works. Based on what we are aiming to achieve, we can go off and choose the route. But whatever we decide, there will be something called a least cost tree. And we will look in this video on how to find or how to calculate this least cost tree. If you see this diagram, this is an intranet. An intranet is a collection of hosts and routers connected to each other. And in this case, we have routers, and these in the middle are LANs. So we have these routers connecting LANs, and they themselves are connected using different types of links. We have wired links and we have wireless, or different types of links, and we also have LAN and we also have WAN, wide area networks. Okay? Now this diagram can be represented in the form of a weighted graph. So every router becomes a node, and every connection will become an edge of the graph. And here we have the cost written next to every edge. So the cost of going from A to B is 2. Cost of going from A to D is 3. The cost of going from A to C through B would be 7. So this is how we represent the internet. Now in least cost routing, the aim is to find the least cost between the source router and the destination router. Here we have A, which is the source, and E is the destination. There is more than one way of going from A to E. We have ABE, we could go ADE, We could even go A, B, C, F, E. So many different ways in which we could go to E from A. But the point here is we need to find the least cost. And in this case, if we consider these two routes, then you will see that ABE has got a cost of 4 plus 2, which is 6. Right? ABE is 6, whereas ADE is 8. So in this case, ABE would be the least cost route between A and E. This will be the best route between A and E. So the least cost tree, in this case, what we do is we take every router and we call it the root. Okay? And then we find out the least cost from this node to every other node. Okay? So if we were to look at this diagram, if we take A, for example, in this example, if we take A, then the least cost tree for A would be the tree that shows us the least cost from A to every other node in the network. So this diagram shows it very well. For example, we have A to B, the least cost is 2. Okay? Remember one thing, when we are talking about direct neighbors, these will always be least cost. Okay? So A to B is 2, A to D is 3, A to C, what's the best route we have? It is through B, 5, 6, 7. So A to C is 7, A to E is through B, so A to E, the least cost we have is 6, and so on and so forth. So if we see in here the least cost tree, there you go. We have A to itself is 0, A to B 2, A to E is 6, and it is showing us how we can get to E. A to D is 3, A to C is 7, similar to what we calculated earlier. So we go off and we do this procedure, taking every node as the root. So we do the same thing with B as the root, C, D, E, F, and G. So at the end of this, we now have the least cost trees for all the nodes on the internet. We now look at different algorithms for calculating this least cost tree. And this will be covered in the next video.